Elizabeth, and I had problem number 27 about the pie that was cooling. The equation was given 70 plus 230 e to the negative k times t equals the degrees in Fahrenheit that the pie has cooled after it's been taken out of the oven. T is measured in minutes, k is a constant, F is measured in degrees Fahrenheit, and after 10 minutes the pie has cooled to 200 degrees. Part A asks when will the pie be 150 degrees, but in order to solve for that we have to solve for k. So before we can even get to A, we have to solve for k using this information. So we know at 10 minutes the pie is cooled at 200 degrees, so the degrees Fahrenheit or F equals 200. So we have 200 equals 70 plus 230 e to the negative k t, and t equals 10. And that's using the information given in the problem. Then if you start to manipulate the equation, you can subtract 70 from both sides, and 130 equals 230 e to the negative k times 10. And then you can divide both sides by 230, and you get e to the negative 10k. What about this? Whoops. It's fine. Where was I? Equals 13 over 23. And then you can use your log rules to get rid of the e. So log base e of 13 over 23 equals negative 10k. And log base e is the same as natural log, so the natural log of 13 over 23 equals negative 10k. And then since we're solving for k, we can divide both sides by negative 10. And then we get k equals 0.0571. And so then we can use that k value when we solve A. So then A asks, when will the pie be 150 degrees? So we know that F in this case is 150 equals 70 plus 230 e, and now that we know what k is, we can have negative 0.0571 t, where t is the minutes. And then we do the same thing and we manipulate the equation, so we can subtract 70 and 80 equals 230 e to the negative 0.0571 t. And you can divide both by 230, and you get, oops, lost my place. 8 over 23 equals e to the negative 0.0571 t. And then from here you can do the natural log. We're just skipping this stuff, the log base e of the log base, we're just gonna write it. And then we divide both sides by negative 0.0571. And you get, that's supposed to be natural. It is log base e, and then that's the same as natural log. So I forgot to write this step, but you would just write underneath before you divide that that's the same as natural log. And then you get t equals 18.4948 minutes. And then if you were to write that in this sentence, you could say the pie will be 150 degrees after 18.4948 minutes. And then at the time in part A, how fast is the pie cooling? So now we have to solve for the derivative of the degrees Fahrenheit, so F prime. And so the derivative of that would be, since 70 is a constant, it's not in the derivative. And since this is like e to the u, the derivative of negative kt is just negative k, since t is the temperature and k is a constant. So the derivative would be negative k times 230 e to the negative kt. So that's your derivative, and then you can plug in values for k and t. So negative 0.0571 times 230 e to the negative 0.0571, and then multiplying by our time, which is 18.4948 minutes. And so when you multiply these values, you get negative 0.0571 times 230 e to the negative 1.0562. And then if you solve that, you get negative 4.5673. So the pie is cooling at a rate of 4.5673 degrees Fahrenheit per minute at 18.4948 minutes. And that's problem number 27. Woohoo!